Picture this. In 1969, NASA sent astronauts to the moon using computers less powerful than your phone. They did it 6 times, then they just stopped for over 50 years. We've got self-driving cars, AI that can write essays, and robots exploring Mars, but going back to the moon? Apparently that's too hard now. How does that make any sense? We had the technology in 1969, but we can't do it in 2025. It's like saying we forgot how to ride a bike after winning the Tour de France. And by the way, if questions like this keep you up at night, hit that subscribe button. Drop your burning questions in the comments, and I'll answer them in the next video. Here's what most people don't realize. The Apollo program didn't stop because we lost the technology. It stopped because it was insanely expensive. Between 1960 and 1973, NASA spent about $280 billion in today's money just to get to the moon. That's more than the entire annual budget of many countries. Each Apollo mission cost roughly $25 billion. For comparison, that's enough to build 50 large hospitals or fund 200,000 full college scholarships. But that's not all. After Apollo 17 in 1972, public interest completely collapsed. A 1970 survey found that only 35% of Americans thought the moon missions were worth the cost. The Vietnam War was draining resources. The economy was struggling. Politicians looked at that massive price tag and said, "What are we actually getting from this?" Now here's where it gets interesting. NASA didn't just throw away the blueprints and call it a day. They shifted focus to something more practical, the Space Shuttle program and the International Space Station. Why? Because these actually gave returns. The ISS has produced over 3,000 scientific studies since 2000. It's tested medications, advanced materials science, and helped us understand how long-term space travel affects the human body. The moon? It's a dead rock. There's no atmosphere, no magnetic field, and not much to study that we hadn't already figured out. But wait, you might be thinking, okay, so they stopped because of money and priorities. But why can't we just go back now with all our modern technology? Great question. Here's the problem. We'd essentially have to start from scratch. The Saturn V rocket that took astronauts to the moon? We don't make those anymore. The factories that built them were shut down decades ago. The engineers who designed them have retired or passed away. Sure, we have the blueprints, but those blueprints assume you're using 1960s manufacturing techniques and materials. A 2005 NASA study found that recreating the Saturn V today would cost between $18 to $24 billion, and that's just for the rocket. You'd still need to build new lunar modules, spacesuits designed for moon dust, and train an entirely new generation of astronauts. Now let me ask you something. What if I told you that going to the moon in 1969 was actually less complicated than going today? Sounds backwards, right? But here's the thing. Back then, NASA had one goal: get to the moon before the Soviets. Safety was important, but speed was everything. They took risks that would be unthinkable now. Apollo 1 caught fire during a test and killed 3 astronauts. Apollo 13 nearly killed its crew when an oxygen tank exploded. Today, with modern safety standards and oversight, each mission would take years longer and cost significantly more. We're more cautious now because we've learned hard lessons. Now here's the part no one talks about. There's another reason we haven't gone back, and it's actually kind of brilliant. NASA realized something crucial in the 2000s. Robots are way better at exploring space than humans. The Mars rovers Curiosity and Perseverance have explored Mars for years on budgets that are a fraction of what a crewed mission would cost. A 2014 study by the Planetary Society found that robotic missions return about 10 times more scientific data per dollar spent than crewed missions. Robots don't need food, water, or air. They don't get radiation poisoning. And if something goes wrong, it's just a machine. But let's move on to the most amazing part. NASA is actually planning to return to the moon. It's called the Artemis program, and the first crewed landing is scheduled for 2026. But this time, it's different. They're not just planting flags and collecting rocks. They're building a lunar base. The goal is to establish a permanent human presence on the moon to test technologies for Mars missions. They want to mine water ice from the moon's south pole and convert it into rocket fuel. That would make the moon a refueling station for deeper space exploration. And here's what really gets me. The reason it's taken so long isn't because we forgot how to get there. It's because the goal has completely changed. In 1969, the moon landing was about proving America could beat the Soviet Union. It was political theater on the grandest scale. President Kennedy didn't care about lunar science. He cared about winning the space race. A 2019 analysis by space historian John Logsdon revealed that Kennedy privately questioned whether the moon landing was worth it, but he knew it was essential for Cold War optics. Today, there's no space race. There's no existential threat pushing nations to dump unlimited money into getting to the moon fast. Instead, we're taking the slow, methodical approach. We're building sustainable systems. We're partnering with private companies like SpaceX to reduce costs. We're thinking decades ahead instead of years. So here's the beautiful truth. We didn't stop going to the moon because we couldn't. We stopped because we achieved what we set out to do, and then we got smarter about how we explore space. Sometimes the most advanced move isn't doing the same thing faster. It's asking if there's a better way entirely. The moon will still be there when we're ready to stay. Tell me in the comments what's the weirdest question that just popped into your head. I'll pick the strangest one and make it the topic of the next video. And if you love discovering the answers to strange questions, then you're definitely going to enjoy this video.